All right. Good morning, all you wonderful people. Let's get started. Let's move over to what we're doing today. Here's our lesson. And solving absolute value inequalities. That's what we're doing today. Rewrite and solve absolute value inequalities as compound inequalities. Now that one we'll get to tomorrow or so. And solve problems using absolute value inequalities. So those are what we're doing. Darn, I was gonna make a meme about this one here. I have one, but it doesn't quite match, but it's okay. I don't know if I still have it. Nope, I don't think I still have it. I'll give myself a second or two to look for it because I knew it was here somewhere. Oh gosh, oops, talk about being unprepared. Oh, there it is, found it. All right, so what number, if I take the absolute value of that number, will give me 7? Now it says, what are the possible values? So that's a clue that we might be looking for something more than just one of them. So probably the easiest thing most people would say is, well, how about 7? The square root of, the absolute value of 7 is 7. Okay, makes sense. Well, there's another. No, there is another. All right, now this is not exactly the same thing. This is for square numbers, but I wanted to make something like this one for this one. Anyway, you can also put in -7. So you have what we call the negative case. So if I put in -7, take the absolute value of that, we will still get 7 because the absolute value of -7 is +7. Well, okay, let's look at this next one. So there you go. We have 2 possible cases that we can use. How about if the absolute value of x is -4? What could we put in there? Well, we could put 4 in there. Let's try that. Absolute value of 4 is, well, +4. And we get +4 equals -4. So that doesn't work out. What if we put in -4? -4, same thing. We still get +4. So neither positive or -4 will work. Neither of them will work. So in this case here, we would have no solution. There is nothing you can put in there that will make it work. So when we go through some of these examples, make sure you keep that in mind, that some of these will have no solution. Or if you remember, there was another thing when we were working on radical equations. And the thing in radical equations, oh wait, well, I'll talk about that in just a bit because we've been working on radical equations for the first 2 weeks of the class. So here are the steps that you would use. Isolate your absolute value expression. So remember that the absolute value signs are grouping symbols. And when you want to work on, you gotta, oh no, huh, weird. Anyway, sorry, you got 2 of the same person in the group. So you want to isolate them, just like radical equations. When we were solving radical equations, I told you to isolate them first. Isolate your absolute value equations. And then you would square both sides or do whatever you need to get both sides to match up. So isolate that first. And then create 2 cases. So make sure that you have one that is a positive, what we call the positive case, and the other one is what we call the negative case. Now, this basically means change the sign of everything on the outside. There's another way you could do it, but I think this one is definitely the easier way of doing this. And it'll make more sense once we start getting into some of the once we start getting into some of the ways, the examples. And then solve both equations and check for extraneous solutions. So just like radical equations, you will sometimes get the wrong answer even though you did the math right. So what is a or an extraneous solution? So okay, so this is one of the blank spots on the packet, on the workbook, on the worksheet that I gave you. Solutions that do not work in the original equation. So you plug them back in, you check it, and it just doesn't work out. You just don't get the exact same thing. And as I sometimes explain it, is you just do the work the right way, right? It's not your fault. You did the work the right way. You followed the steps. You followed exactly what you were supposed to do, but it just doesn't work out. And again, that's not your fault. Sometimes it be like that. Okay. Oh man. Oof, a little sleepy today. I don't know what the deal is sometimes. Sometimes I can't sleep and I'll fall asleep. I'm guessing around midnight or something. I wake up, I'm fine. Other times, like last night, man, I went to bed like right on time, like exactly the time I usually want to. But now I'm tired. It's like, it just doesn't make any sense, you know, like, come on, body, do you want more sleep or less sleep? Okay, I'm pretty sure I already know the answer to that, but let's go ahead and start working on this one here. So I have the same thing. So I'm going to keep what's inside of the absolute value sign the same. But again, I'm going to change this number on the outside. So I'm going to create the negative case first. Now you can do this either way you want, but I'm going to do the negative case first just so you don't forget it. So it's just a little bit more memorable. And for this one here, I'm going to leave the case the same. So everything is pretty much the same. I just left it positive. Now I'm going to have to solve both equations. So I'm going to do one at a time for most of these if I can. So add 9 to both sides. X equals, and then I have negative 5 plus 9, or I'm going to think of it as 9 minus 5, which is just going to be 4. Now, I'm going to check most of these, you know, I really should write all of them out when I'm checking them out. Like 4 minus 9 absolute value equals 5. So 4 minus 9 is negative 5, and the absolute value of 5 is 5. Sorry, absolute value of negative 5 is 5. So this works out. That is a true solution. So we know this one works. But again, as I was saying, I won't have enough time or space to write all of these out. So for some of these, I'm going to just do them kind of in my head and hope that you follow along. I know it's not the ideal situation. If I had more writing space, or if I had, you know, the bigger board to write on, that would make a lot more sense, but I don't. There's not really a way I can make it work. Trust me, I've tried. All right, so I'm going to add 9 to both sides so that x is by itself, and positive make a bigger positive, so x equals 14. And let's check this one out. So like I said, in this case here, I have enough space, so I'm going to write it out. And I would encourage you to write all of these out as well. So 14 minus 9 is 5. And the absolute value of 5 is 5, so that's true. So this one also works out. It is a true solution. And most of these are going to have 2 solutions. But again, be careful, because there are times when you will get extraneous solutions where sometimes neither of them will work, or maybe just one of them will work. All right, so same thing. I'm going to use the absolute value sign, and I'm going to create a negative case. And again, I'm only doing the negative first this time around, so that way you learn to pay attention to that one first. And then I'm going to create a case where there is little change. There is no change, I should say. which we call the positive case. So again, two possible answers. Let's work them out. So I want to get this k by itself, so I'm going to have to get rid of this 7. So minus 7 from both sides. This side will cancel. Negative 3, negative 7, put those together, you get negative 10. Negative 10 equals 2k. Can it keep going, right? Because now we have what number times 2 gives me negative 10? Well, if we work backwards, if we do the inverse, we should be able to get that. Now I'm going to put k first because I'm just going to use reflexive property and just switch them around. K equals negative 5. There we go. And then we check it really quick. So again, like I can't write them all out. Like in this case, I have no space to write anything out. But on the assignment, on the papers that you have, you should have enough space to write all this stuff out. It shouldn't be that big of a deal. So let's go ahead and plug it back in. 2 times negative 5 is negative 10. Negative 10 plus 7 is negative 3. Take the absolute value of negative 3, you get positive 3. So that's a working solution. See, not so bad. Some of these, there's like 2 of them that are going to be a little bit bad. But shouldn't be nothing you can't handle. All right, so let me go ahead and cancel this 7, right? Because I want that k by itself. So negative 4 equals 2k. And I still got to get that k by itself. So still divide both sides by 2. K equals, this 2 is canceled out. So now k is by itself. And again, I'm going to switch the sides so that the k is first. Negative 4 over 2, so negative 4 divided by 2 is negative 2. There we go. And again, let's check it really quick. 2 times negative 2 is, well, negative 4. 7 minus 4 is positive 3. Absolute value of 3 is 3. So that works out. That is a working solution. Okay, no problem so far. Let's see if these ones are going to be the same type of deal. And again, it even says right there in the directions, check for extraneous solutions. So that's usually a hint that you might have some extraneous solutions. All right, so with these ones here, we are going to have to isolate that absolute value first. So that's what I'm going to do. I'm going to isolate it by getting rid of this 17. Since I'm adding 17 in the equation, I'm going to minus 17 from both sides. And I end up with my, I could probably jump straight into the cases from here, but I'll save that for later. So 23 minus 17 will be 6. And we still have the absolute value signs here. So from here, I'm going to go ahead and break it into the 2 cases. And again, just for simplicity's sake, I always, when I'm going over this, I usually have the negative case go first because that's usually the one that people forget. So negative case, so again, same thing in here on the absolute value, nothing's changed. But on the outside, that's what's going to change. So now it's going to be a negative 6. Y minus 1 equals, and then this one's going to stay the same, so it's going to still be positive 6. Now that I have my 2 cases, let's go ahead and solve both cases. So I'm going to start with this one here. Add 1 to both sides. Y equals negative 5. Over here, add 1 to both sides. Y equals, and then 6 plus 1 is going to be 7. Now, again, we have to check all of them. So let's check it. So -5 is y. So -5 and -1 make -6. Take the absolute value of -6. You get +6. 6 plus 17 equals 23. So this is a solution. Let's try 7. 7 minus 1 is +6. Absolute value of 6 is 6. 6 plus 17 is 23. So same thing, we have another solution. So this one has two solutions that you can plug in and both of them will be correct. All right, for this one, number 6, we have again, don't forget that absolute value sign is a grouping symbol. It's just like a parenthesis, and you should try your best to work on those first, but in this case we can't because I cannot add m and 8 together. So we are going to have to get rid of that 3 because we need to isolate it. So how do we get rid of that 3? Now again, remember, this means 3 times this group with m. So that 3 is multiplying to the m. So we need to do the inverse operation, which is divide by 3. And that cancels the 3 here. So now there's no more 3. M plus 8 equals, and then 39 divided by 3 is 13. From here, I can go ahead and make my two cases. So that's exactly what I'll do. So I'm going to make my negative case first. M plus 8 equals -13. And it's easier to change the outside than what's on the inside of the absolute value. So that's why we change the outside. I mean, you could change the inside, but I'd have to change 2 things in this case. And it's easier to change 1 thing than it is to change 2 things. That's why we usually reverse the outside. But then I've never used that method long enough to know if it's gonna always give you the right answer. I don't know, maybe there's like some random cases out there that'll make it not give you the right answer. Okay, sorry, subtract 8 from both sides because I got to get that m by itself. M equals negative and negative. We'll make a bigger negative, so that'll be 21, I believe. I'm going to erase this just so I can go back to my original a little bit easier. So let's plug this in. 21, well, negative 21. So that would be negative 21 plus 8, so 21 minus 8 is going to be 13, but it's negative because remember it's going to be negative 13 because I'm subtracting from a bigger number. But it's negative 13 inside the absolute value, so that's going to mean, well, negative 13 absolute value is positive 13. 13 times 3 is 39, so this is a working solution. And you see, even some of these checking, they don't take that long. All right, that probably, if you were to time me from start to finish, about 5 seconds. Okay, minus 8 from both sides, so this cancels. M equals, and then 13 minus 8 is going to be 5. And let's plug 5 back in and see what happens. So 5 plus 8 is 13. Absolute value of 13 is 13. And again, it's a grouping symbol, like a parenthesis, so you multiply when you have that there. So it's going to be 3 times 13, which is 39. So this does work out. So that is a working solution. All right, making pretty good time. I'm gonna move over to the next one where we have these. And again, we have a multiply times the absolute value. So again, it's treated just like a grouping symbol. First thing I want to do is divide both sides by 16. So I can get this 16 out of the way. And I get r minus 5 equals negative 2. And the absolute value sign is still there, so we didn't do anything to get rid of it just yet. But we got to get rid of it by making our two cases. So r minus 5 equals 2. So I'm going to reverse it. So the negative case doesn't always mean turn it negative. It just means it's going to have the opposite sign. So if it has a negative, it's now going to have a positive. But then one of them is going to stay the same. So in this case here, I did not change negative 2 or negative 2 here. Still the same thing, did not change it. So let's go ahead and solve these. So add 5 to both sides. R equals 7. So let's go ahead and plug that back in. I'm going to erase this so it's easier to see our original. 7 minus 5 is 2. So 2 times 16 is positive 32. And positive 32 is not the same as negative 32. Even though it's the same number, they're not the same number. Well, they both have the same absolute value, but they are not the same number. So this is not a solution that works. This is an extraneous solution. Okay, well maybe we could still save this one. Maybe we could have one of these. R equals, and then 5 minus 2. So 5 minus 2 is going to be 3. So plug 3 in and let's see if this works out. So 3 minus 5. 3 minus 5 is going to be negative 2. But it's still absolute value, so that's going to be positive 2. 16 times positive 32, or sorry, 16 times positive 2 is positive 32, but not negative 32. So this one does not work either. So this one has no solution. Okay, there's nothing I can put in there that's going to work. And sometimes it's just like that. Now, one big clue that you can use to see whether or not you will get an answer or not, or a solution, I should say solution, is if your outside number is negative. So in this case here, I have a negative 4 that is just sort of by itself. And in that case, the outside number is negative. So whenever you have an outside number that is negative, that's usually a clue that you are going to have no solution. But again, in this case, it might be worth it still to just work the problem out and plug it back in and see if it works. All right, so let's go ahead and do this one here. Now I have 2 on the bottom, and see how over here, I had a times by 16, so I divided by 16. Same thing. If you have a problem like this, I'm going to cover this up just so it's a little bit easier to see what's going on. I'm going to multiply both sides by negative 2. Multiply both sides by negative 2. And that cancels this here on this side. So y minus 10. Absolute value equals positive 12. Okay, so now from here, I can go ahead and create my two cases. Y minus 10 equals negative 12. So again, have your negative case. And I'm going to have my positive case, or everything stays the same. Everything stays the same. You just get rid of that absolute value. Well, you evaluate the absolute value. Basically, it means you used it. So it's gone now. Continue solving. So add 10 to both sides. y equals, looks like -2. And again, it's important that we check all of it. Always, every answer, check it. So I'm going to erase these just so that way we can see it a little bit easier. So y is -2 now. So -2 minus 10 is going to be -12. But again, take the absolute value of -12. You get +12. +12 divided by -2 is -6. So this works out. Add 10 to both sides because I do want that 10 to go gone. By the way, don't ever speak like me. I do that just to just to mess with people. 22. So 22 minus 10 is +12. Take the absolute value of +12. You get, well, +12. +12 divided by -2 is -6. So this is a solution. Plug it in. And again, I would suggest you write all of these out. If you look at your packets, they have nice little big boxes that give you plenty of room to check your answers in. But just to save room on these slides, I don't really have that. Plus that too, again, if I had to write each of these, it would take much longer. Okay, so let's go ahead and move on to these next groups. So it looks like we're gonna have to do a little bit more work on isolating these before we solve them. Okay, so on number 9, I have that absolute value, but I also have a -11 there too. So I got to get rid of that -11 in order to isolate that absolute value. So add 11, add 11. So 11 minus 5 is 6. 8 minus p . All right, now from here we can, oh wait, I still have my absolute value signs, but now I can break it into two cases. The negative case, and again, everything on the inside stays the same, and then the positive case. Solve both sides. So I want this 8 out of here, so let's go ahead and get rid of 8. That cancels the 8 here. And I'm just going to do the old reflexive property, and I'm going to switch sides so that I get -p, right? Because the only thing I have on this side is -p. Since it's the only thing, I'm going to have it switch sides, and I'm going to take whatever's on this side and move it over to this side. So -6, -8. It's going to be -14. But we're not done yet because it's not solved, because we have to get that p entirely by itself, which means no negative either. So no negative. I'm going to go ahead and divide both sides by -1. And I've seen different things too. I've seen other teachers multiply both sides by 1. And there are actually a couple of other things I've seen done too, but I'm going to just stick with this because I think it matches what most people already believe. P equals 14. But let's check that really quick because we might get an answer that doesn't quite work out. So 8 minus 14. So I'm subtracting a larger number. It's going to be negative, so that's going to be -6. Absolute value of -6 is +6. 6 minus 11 is -5, so it is a working solution. And again, don't be afraid to write those out. If you need to, write it out because it gives you plenty of space. You have like this much space on the work. But again, I got to save slides here. These slides aren't free, you know. -8 on both sides. Okay, and that cancels 8 here. 6 minus 8 is going to be -2. equals negative p. Now with these, you can also just flip both signs. That is literally what you're going to do. And I'm also going to use reflexive property here, so the negative cancels out. So I always want the variables to go first. Again, you know, you say like the p is 2. You don't say the 2 is p necessarily. Like if I said Peter is 2 years old, it sounds weird if I say 2 is Peter. See what I mean? That's just the way English is. You talk about your subject, then your adverb or adjective. Adjective. I'm not an English teacher, by the way. I'm not very good at English. There's a lot of things in English that just don't make sense to me. Well, I grew up in a household where English wasn't spoken all the time. So I guess it kind of made me a little bit more, it made me pay a little bit more attention to how English works. And I could be here all day talking about all the weird things that English does and things, you know, but that would take forever. I could literally make a whole class of it. Anyway, let's go ahead and get rid of this 9. So again, we got to do the inverse. And since this is a divide by 9, inverse of divide is multiply. So I multiply both sides by 9. That gets rid of our 9. So I have 3a plus 12 equals 0. And I'm going to go ahead and make my alternative case here. But you're going to notice something is going to be a bit off on this one. And I said this during the real numbers property lesson, and that is there is no such thing as -0. All right, there's no such thing as -0. So 0 is just 0. So I can't put a negative on a 0, so I end up with the exact same thing. So I don't have a second case. All right, so minus 12 from both sides. Not a bad. Divide both sides by 3, and a equals -4. A equals -4. And let's check it really quick, make sure it works out. -4 times 3 is, wait, okay, -4 times 3 is -12. -12 plus 12 is 0. 0 divided by 9 is 0. And that works out. 0 divided by 9 is 0. 0 divided by any number is still going to be 0. So that is a working solution. There you go.
Mr. Nez.
Did I make a mistake?
For number 9, the p equals 2. When you put that in and check your work, wouldn't it be -6 because you changed it again? And then it'll equal to -17.
Well, okay, so let's go ahead and do that. I don't know. You might be right on that. It's not the first time it would have happened. Let's try that. 2 minus 11. So let's go ahead and let me just double check that, make sure I wrote everything right, because it wouldn't make sense to do that if I miswrote it. 8 minus 2 would be √6 minus 11. Now, in this case here, remember the absolute value does not switch the signs. It basically just makes it positive all the time. Like a washing machine, it'll always make your clothes clean. Unless you forget to put soap in it, then it just gets it wet and swishes it around. But I think even then it would still be clean. Come to think of it, I wonder how washing machines work. I mean, is it really the soap? Because I've done that once without soap and it actually came out pretty not bad. 6 minus 11 is still -5. No, that's good. I mean, it worked out. So yeah, 2 is still a working solution. Again, be careful because it doesn't mean switch the sign. It just means it's always positive. Because in a negative situation, I'm sorry, in a absolute value means a number's distance from 0, and distance cannot be negative. If you walk 6 steps backwards, you're still going positive 6 feet in one direction. So yeah, okay, that one does work out. But again, it wouldn't be the last time it wouldn't be the first or the last time I'm ever making a mistake. But again, mistakes, they're not bad. You know, I make them from time to time. That's one, why we check them, and 2, that's why I tell everybody you should always check yourself, because you know, if I make mistakes, chances are everybody does. And I think people beat themselves up too much when they make a mistake. You know, like some students, if you tell them, oh man, you got this question wrong, they'll be like, oh no, I'm a failure. I have brought dishonor upon my family. No, just try again. Okay, that's all you need to do. Okay, it's not like your mistake, you know, caused a bridge to collapse and all that stuff. No, it's just a tiny one. Not the end of the world. Anyway, speaking of common mistakes, this one right here, I always see people do things like this. They'll go 9 minus 4, and I'm like, wait, isn't like addition and subtraction like the last thing on the order of operations? Which is true. It is the last thing, but I see people do this all the time where they add the outside numbers. Okay, those are not grouped. These are grouped. And if you have a number next to a group, that means multiply. So the real first thing you would do is move that 9 over to this side. Okay, that looks like a times, but it's a plus. It's just, well, you know what, let me just fix that instead of mentioning it. There we go. Now I still have the absolute value sign here. I should have given myself a little bit more space here and here. So what I need to do now is I got to get rid of this 4, because again, it's got to be isolated. So I'm going to have to divide both sides by -4. And that gets rid of that. And so since this one's going to take a few more steps, I am going to create my 2 cases now. So C plus 10 equals negative, and negative is going to be positive. Okay, so I guess I'll do my regular case first. Now I'll do my negative. So you know, it doesn't really matter. I think most teachers or most textbooks, anywhere I usually look, usually saves the second case for the second case for the negative one. The negative case is the second one. Doesn't matter. Doesn't matter as long as you do both of them. There you go. So now I have my 2 cases. We just need to solve for C. C equals 6 minus 10 is -4. And let's check that out really quick. So plug in -4. So this is 10 minus 4 is 6. Right, take the absolute value of 6, that's 6. 6 times -4. 6 times -4 is -24. I'm sorry. Wait, yeah, it is -24. 9 minus 24 is -15. So this is a working solution. Now we got a -10 from here and here as well. C, oopsie, that's a terrible looking C. Nope, still not good. C negative 16 negative 16, plug that back in. So negative 16 plus 10 is negative 6. Take the absolute value of negative 6, you get positive 6. Positive 6 times 4 is 24. 9 minus 24 is negative 15. So that is a working solution. All right, now it's always these ones with the fractions. These are always the ones that people are chomba scared of. You know, like if a Navajo lady wants to scare her kids, she goes, "Ah, damn fractions." Okay, I messed it up, but you get it. I think people already know that one. That's if you were raised John like me. But I'm pretty sure everyone uses that trick all the time. Anyway, let's go ahead and get these two negatives. So negative 24 equals, and I got to get rid of this negative 12 here. Let me go ahead and get that K. Okay. Whew. I have to get rid of this 12 here. So I got to divide both sides by negative 12. And again, cancel the negative, cancel the 12. Now I have K over 5 equals negative divided by negative is positive, and 24 divided by 12 is 2. And now I can create my two cases. And I did the same thing, reflexive property. I just switched the sides, you know, whatever, everything on one side just moves over to the other side pretty much. K is 2. Now I should have wrote this a little bit different. I wrote it off to the side because it's a fraction. It takes up a little bit more space. So I need to times both sides by 5. Oopsie, I should also create my negative case as well while I'm here. That way I don't forget it or forget which one was which one or anything like that. So K equals 10. And same thing with this side, multiply both sides by 5, and it looks like K equals negative 10. Now this one is a bit of an interesting one because I have two of the same numbers, but they are opposites, positive 10 and negative 10. Now, since I'm checking an absolute value equation, check it out. If I put negative 10 in here, divide it by 5, I would still get positive 2. Same thing here, 10, plug it in, divide by 5, I get positive 2. Take absolute value, you still get positive 2. So for this one, I'm going to check both of them at once. Now again, this works when they're both the same number, but just opposites. So we know this is 2. 2 times negative 12 is negative 24. Negative 24 plus 8 is negative 16. So we know both of these are solutions. Yeah, close enough. There we go. Now I was talking about how English language is kind of a mess, and a lot of times people don't really think their own language is hard to learn because it's the one they grew up speaking. But one interesting one is the word driving. So like if I ask you, how did you get here? You know, like if I ask a coworker, how did you get here? They would most likely say, I drove a car. And the word drive comes from cattle driving. So if you know anything back in the old days before the invention of cars, you would ride a horse and you would herd cows with it. That's called cattle driving. So when they attached a carriage to horses, the person was called a driver. So when cars were invented and the horse was removed and replaced with a motor, they still called it driving, and we still call it driving to this day. But if you go to most other countries where they didn't have a transition from carriages on horses to, or horse-drawn carriages to motorized vehicles, where sort of motorized vehicles just appeared overnight, they didn't see this progression, so they came up with new words. So in most other languages, the word driving a car often translates to piloting a car. So piloting is like more the way that you would sail a boat. You know, and that makes more sense because driving a car is more like sailing a boat and less like whipping cows in the back. And again, it's just a small thing that most people don't even really think of. But English is just full of these sort of things. And I'm sure you've seen them pop up in memes too, like, you know, if it goes by car, it's a shipment, but if it comes in by ship, then it's called cargo. All right, there we go. So with this one, I went ahead and left it the same on the first one, x plus 1. And for the negative case, I switched both of them. And I'm going to move this over just a little bit so I get more space. And I'm going to put a line here because since it's a lot of writing, I'm going to go ahead and make it so they don't get mixed up. Okay, so that's what happens. Again, remember when you're switching to the negative case, you got to switch both of them, which is kind of a weird thing, but yeah, you got to reverse everything on the outside. And you could also reverse things on the inside too, but that would make things tougher because you'd have to make all of these different. You know, you'd have to change, like in this case, it would be negative c minus 10 on all of these, and that just makes a lot more work. Okay, so let's go ahead and get this here. And I'm going to minus x from both sides. And since I canceled this here, I'm going to cancel the 9 over here. So I'm going to add 9 to both sides. And looks good to me. Did two things at once, so I don't have to make an extra step. And x equals 5. And with this one here, I don't think anything weird is going to happen. Let's just check it again really quick. That'd be 15. So 3 times 5 is 15. 15 minus 9 is 5. 15 minus 9 is 5. Wait, no. 15 minus 9. 6. Okay, 6. So absolute value of 6 is 6. But then 5 plus 1 is also 6, so 6 equals 6. Okay, there you go. And let's go ahead and do this one here. Now, it looks like I'm going to have to add x to both sides. But at the same time, since I cancel this, I'm also going to add 9 to both sides so that I move this out to over here. And that's going to cancel the 9 over here. And like I said, I always call it the trade, where one side wants the variables and the other side wants regular numbers. And since each side has what the other one wants, they just trade. And that way both sides are going to be happy. And what number times 4 gives me 8? 2. Let's check this one. 2 times 3 is 6. 6 minus 9 is negative 3. But if you take the absolute value, you get positive 3. I'm going to write it here just that way I don't forget it. 2 plus 1 is 3, so I get 3 equals 3 if I check it. So this is a working solution also. And I want to isolate this one here. So again, I'm going to isolate it by dividing both sides by 2. So that outside multiply goes away. So I get h plus 8 and 7h. Now while I'm here, I'm going to do the same thing and just save myself a little bit of writing. And I'm going to create the negative case right here as well. Okay, now we can go ahead and solve both sides. So minus 8. Oh, hold on. I should really look at what's going to happen with this here first, because in this case here, I would rather minus h first. That way I keep it positive if I can. 8 equals 6h. Divide both sides by 6, and h equals, they're both even, so I'm going to divide them by 2, so that'd be 4 over 3. Now, I think that one, well, okay, so to test it out, this one's going to be a tough one to test out because I am going to have to do a little bit of work on it. So 4 over 3. When you plug it in, it'd be 4 over 3, so this would be 8 plus 4 over 3. You might just need a calculator to do that one, to check it out. But it works. Oh man. Yeah, that one's a bit of that one's going to be some work. And for this one here, let's go ahead and work with our h first. So I'm going to move this h and add 7h to both sides. But I guess I'm also going to minus this 8 here, minus 8. Combine like terms, so h plus 7 is 8h equals negative 8. And in this case here, divide both sides by 8, and h equals negative 1. Now if I check this one, let's check it. So negative 1 plus 8 is 7. Positive 7 after we use the absolute value. So 2 times 7 is 14. And negative 1, plug that in here. So negative 1 equals 14. You get negative 14. Negative times positive. Okay, so that's not going to work. So this is an extraneous solution. So that leaves us with only this as our solution. So this one only has one solution. And again, sometimes it be like that. So there was no hint that this one was going to be weird. If anyone was going to be sus, it would be this one. Sus is suspect, by the way. I don't know why people started saying that, but people started saying, oh, that's awfully sus. Kind of like I learned a new word over the weekend. I learned the word poggers. It's a way of saying awesome, I guess. Like, oh man, that hot and spicy McChicken was poggers. Probably not gonna, I knew it. Tell me no, don't use it. Don't say that. Now that I know it makes people upset, I'm gonna put it on everything. No, I'm kidding. I don't think anybody in here would even say that either. Usually Tuba City's like that. They don't go with trends, especially internet trends. And usually when people do something like that, it's usually something like different or something. But that's one good thing I like about Tuba City is that people oftentimes reject weird things like weird hairstyles and weird music, you know. I mean, to some degree, it's okay to like new things, but then at some point, it's just like, I don't know, like kids never used to say YOLO all that much, and when they did say YOLO, it was more in, it was more of like a joke or mocking people who say it, rather than actually using it the way it was supposed to be used. Okay. Ooh, this one's a long one. All right, let me double check to make sure I got the right signs. 6n plus 2, negative 6n plus 2. Oh, see what I mean? Almost made a mistake there. That's why you check yourself. So on that one there, the outside number should also be negative as well. Let's go ahead and do this one. Okay, so I want to get the n by itself. And you know, I'm going to do the opposite I did from the last one. I am going to move the n over to the left, sorry, but that's going to make it negative. And that works too. Okay, it's not bad or anything. So this cancels and this cancels. So this is going to be negative 8n equals negative 6. Divide both sides by negative 8. Cancel the negative, cancel the 8, cancel the negatives. So if you have a negative on top and bottom, they cancel each other out also. So you get n equals 3/4. And again, when you have some of these with fractions, just use a calculator. That would be 0.75. And if you were to put 0.75 into both of those and work it out, it would work out on both of them. But in this case here, let's see what we can do with this one. I'm going to go ahead and add 6n to both sides. All right, now 4n equals negative 10. Is it negative 10? Well, let's just keep going. Now in this case here, n equals 10 over 4, which we can turn that into a decimal as well. So decimal here. So negative 2.5, and I'm going to plug that back in. And again, this is one of those ones that's going to take a little bit of work. So 2 minus negative 2.5, that would be 0.5 on this side. And over here, I'm going to check it again. So negative 2.5, so 2.5. So that would be 5. 8 minus 5 is 3. 3 minus, okay, hold on, negative 2.5. Now this is why it's a good idea to write it. You know, I'm just gonna make this one the last one for now. This one I don't think it's not really that tricky. There's nothing really going on. But I'm gonna just check both of these, and it's just about time anyway, so let's go ahead and do that. So 2 times negative 2.25 minus 5 times, yeah, and again, you should be checking with all of these like this, but you know, I understand that sometimes it just doesn't quite work out that way. Okay, so I need one of these things here. So 8. Now negative times negative is negative, so that would be here, so that'd be 8 plus 5, which would be 13 minus, and then I'm going to work on these two. So negative 2.5 times 5. So if I double 5, I get double 5. That's 10. 10 plus 2.5 is 12.5. 12.5, and that'd be plus, because negative times negative equals 0.5, negative 0.5. And if this was negative, like negative 13, it would work out. But I can tell this is not going to work out, which means this is not a solution. And again, if you use a calculator and put this in for 0.75, that is going to work as a solution. So in this case, we only have one solution. All right, I guess so. This one shouldn't take that long, negative 4w minus 2. I'm going to just leave this one the same, so it'll be our positive case. And I'll make this one the negative case. So if I make it the negative case, the only thing that's tricky about this one is that it's already negative. So you just reverse the sign. So in this case, it was negative 2. So it should be positive 2 when I rewrite it. And there we go. Now we just got to solve both of these. And again, that's the only tricky thing. If you know that, then everything else is going to be easy. I mean, Poggers. Oh, wait, no. I would have to change this one here. I'd have to minus 20 from both sides because I'm moving it to the opposite side. Whereas over here, I let it be a negative, but here I'm gonna move it over so it becomes a positive, and then just move it over later. Let's see, 6 plus 4 is 10. Oh wait, that's supposed to be 20. No, wait. Negative and negative, that'd be negative 22. And this is W. So W equals, and I'm gonna have to divide both sides by 10. And again, I'm all out of space. I can't check this one, but it works. And that one, if I turn it into a decimal, is gonna be like 2.2, I think. So that one should be easy to convert. Let's go ahead and do this one here. So I'm going to do the same thing. I'm going to move negative 4 over here, and that should cancel it here. And again, I'm not an English teacher, but it also just, I mean, I'm just thinking about that word I was saying earlier. I'm like, so Poggers ends in S, which means that it's either possessive, like for instance, that's Sarah's phone, ends in S, or it's plural, like bags or anything that ends in S is usually many of that item. So I don't understand. I mean, like, wouldn't it just be better to just say Pogger? Anyway, that's it for that one. So that's it for all of what we have today. Yeah, that's pretty much it. If you have any more questions, I'll stay around for a bit. If you need anything else, then as always, that's going to be it for today.